Okay, so the recording is in progress, so we can go ahead and get started if anybody has any questions they would like to start with.
I had a question about whether or not we'll need to memorize the formulas or whether those will be provided on the exam.
So yeah, so this exam does have some formulas such as estimating the number of species. So let me open the exam and double check. So the exam itself does include some formulas such as things like the Simpson's index of diversity. That formula will be included. Is there any other actual math? So for this exam, if you need to use a formula, it will be provided.
Awesome, thank you.
Yep. Are there any other questions about the course, the exam, like its structure maybe, or the anything from Cogbooks that we want to review?
I have a Cogbooks question.
Sure.
So there's a lot of videos when you click on like you want to study more. Are those good videos to go off to study for the exam, or is it better to look at the Cogbooks textbook content?
So those are considered supplemental materials. They're not, none of the exam questions are specifically written based off of that text. It's meant to be extra in case you didn't understand the main text from Cogbooks. It kind of explains the same topic in a different way to try and help us understand it a little bit more. So for the exam, I would focus specifically on the main text and use those as extra information to help understand some of that main text.
Okay, thank you.
But if there's an example in those examples will not be brought up necessarily on the exam. The examples would be from the main text. So I guess that being said, if you don't look at the supplemental materials, you won't miss anything for the exam.
How many questions will be on the exam?
The exam is worth 100 points, and the number of questions kind of fluctuates depending on how many short answer questions there are. So there's about 20, there's 25 true, false, or multiple choice questions, and then there will be 6 short answer questions. And
Okay, thank you.
those 6 short answer questions will be also worth 50 points. So it's half the points are in the true, false, multiple choice, and half are in short answer.
Okay, awesome.
I have a quick question.
Sure.
What types of, this is directly like based for the exam, what type of what's like the formatting of the short answer questions? Is it like you write a paragraph, you write definitions? Is it your multiplication?
It could be any of that, but sorry, go finish. Sorry.
I was just wondering if we could like go through a couple examples just so we kind of know what to expect.
Sure. So I think some good examples might be if we look at the topics and learning objectives for for module 1. So, I mean, the first one just says, contrast 3 ways that biologists define biodiversity, right? So you'll have to write out the 3 types of biodiversity and define those different biodiversities and explain in a few sentences on how they're different. And there's no exact formula, like, because they are worth anywhere from 5 to 15 points for the short answer. I would say a loose suggestion is if they're worth more points, you're probably expected, to write a little bit more detailed of an answer, so more in the length of a short paragraph. If it's maybe 5 points, that might, 3 or 4 sentences would probably suffice for that. So kind of use that as a loose guideline. The number of points is kind of how in depth you kind of should write your answer.
Okay, thank you.
But it could also be, another example could be, number 2, even like a math question where you could be given a table like you were in the example, and it might ask you calculate, estimate the number of species in the 2 communities, which one is likely to have more species and why. So it's part math based on a calculation and then an explanation explaining it. It could give you a scenario and ask you to, explain why. They can think of it, it's always going to have a why component to it. That gives it kind of the writing part. So it will be more than just straight definitions.
I had another question in regards to the examples provided in Cogbooks. Are we going to need to recall like specifics from those examples or just the concepts that they, display?
It could be a little bit of both, but if I ask you to recall a specific example, it's likely going to contain some of that information in the question to like recall this example about this, this, and this, explain why we saw this positive effect or this negative effect. So
Okay, that makes sense.
Okay, good.
I had one more question. Would you be able to go over evenness and rank abundance curves? Just because it's kind of confusing me. I start to think the larger you have like in an ecosystem, I'm getting it like backwards as far as like your level of extinction. So would you be able to just go over those curves for me?
Sure. So I think, let me see if I can share my screen. So can you see these 2 plots that are being, well, maybe not yet. Are the plots visible on your guys' end?
No.
Okay, it says your screen share is loading, so actually it's taking a second. So just talking about it, if in a rank abundance curve, if it has a value of 1 or 5, what's the difference in that numeric value? Does anybody know that answer yet, or?
No.
Okay, that's fair. So if there's a value of 1, that means that it's ranking that species that has the highest abundance. If it has a value of 2, it's the second highest abundance. And as we go up, it's the lowest abundance by species. So a low number is the highest ranking, meaning it has the most species on that curve. That species has the most relative abundance for that population. So in these figures don't specify that these are necessarily different species, but each dot is a different species. There's no key with it, which would have been maybe a little bit helpful, saying, species 1, 2, 3, 4, and 5. And then we could say, species 1 has the highest rank abundance, species 2, species 3, and so on. But these plots visible now, right?
Yes, they are.
Okay, cool. It just had a little bit of delay. So why don't we talk a little bit about these curves and what kind of information we can get out of them. So if we want to talk about species, let's just focus on this left plot right here with community A and community B. If we ask which community A or community B has the greatest richness, what would we say and why?
Would it be community B because it's staying constant versus getting, or like it's like decreasing over time?
Well, this is not a time on the bottom. Remember, this is the ranking. So this is the highest ranking species, has the highest relative abundance. So there's no change over time. It's just comparing different communities or different species within a community. Sorry. Well, let's back up. What do we mean when we say species richness? How do we define that?
Is that the number of different species within the community?
Yeah, so we just have the number of species for richness, right? So if it's a flat line, what does that mean for richness?
That it's staying the same.
Yeah, so there's going to be the same number of species in community B, right?
Yeah.
And community A has different number of richness because it has different level of relative abundance of the different species. What about evenness? Now that's where I think we got a little ahead of ourselves with the previous answer. Which community would have the greatest evenness?
That would be community B.
Yeah, right, because it's even for all the species, and this one has a slope to it, right? So a flat line is going to be an even community, and any kind of slope is going to not have complete evenness. But I guess, I don't know if we fully answered it. If we look at community A and community B for richness, what did we say an answer for which one has the greatest richness?
Are they the same?
Exactly. Why are they the same?
Because they have the same number of different species, their relative abundance is just different.
Exactly, right? They each have 5 dots, and those dots all represent a different species. So their richness is the same, but they have different evenness because they have different slopes. So we can get 2 types of information out of this figure. Now let's move over to the right plot. If we look at the eucalyptus plantation versus the primary forest, which one has is there a difference in species richness? And if so, which one has a greater richness?
Your primary forest would have a greater richness because
I
there's more,
agree. And go ahead, because of why?
because there's more species than the eucalyptus plantation.
Yeah, there's a lot more green dots for the primary forest than there are purple dots for the eucalyptus plantation, right? So we can say that there's more species here, so it has, greater species richness. Now, what about when we talk about species evenness? Because that's the comparison of the relative abundance. Which population is more even, or community is more even?
That would be the eucalyptus plantation because there's less margin in between the species.
Yeah, right. So you just go from the top to the bottom dot. It has a slope to it, right? So there is some unevenness, but the green one goes from up here all the way down here, so that's a larger slope, so there's more unevenness. So the primary forest has less evenness than the eucalyptus plantation. Does that make sense? Are there any other questions kind of about this figure? Yeah, but that was a good question, because sometimes it can be a little difficult getting multiple pieces of information off of these curves. And we did get a couple questions through email. So if there's no immediate questions right now, there's a couple questions I could go through as with the group here from the students that emailed them in. This doesn't take as long to share the screen. All right. So can everybody see the estimating the number of species page I'm sharing?
Yes.
Okay, so with this one, what we're given is a formula. So S is the estimated number of species. S sub OBS, what does that stand for?
Is that the species observed?
Yes, that's the number of species we observe. And how, this is not a trick question, it is meant to be simple. How do we know from a table like this if we observe the species or not? That is, how do we count the species observed? Right? There's 12 species listed here, but does every community have 12 species observed?
No,
And how do we know they're not observed?
because they have a 0 by their name essentially. Like in community
Yeah.
C, fingernail clams doesn't have any observed.
Yeah, so these, what, 1, 2, 3, these 4 species over here in community C had 0. So these species observed for community C would be 8. All 12 species for B were observed, and all 12 for A were observed. So species observed values there would each be 12. So that's why we have here species observed in the calculation for community A, it's 12. Now, what does F1 stand for?
The amount of species where one individual was observed.
Exactly, right? So for this community, you have isopods, diving beetles, and dragonflies. So that's why F1 gets values of 3 for these two right here. And then F2 is what?
How many species had 2 observed?
Exactly, right? So for community A, there's ram's horn snails and amphipods, right? So that's why it gets a value of 2 right here. And this 2 that's already in the formula, that's just part of the formula, like -1 plus 2. That's just part of how they originated the calculus. And then you plug the numbers for species observed, F1 and F2, and we can do the arithmetic, and we would estimate that there's actually 13 organisms in community A, or 13 species, rather than organisms, sorry, in community A, even though we only observed 12. And why would we estimate there are more than the species observed? What would be some reasons for that?
Would that be because we can't exactly say how many species there are? We can just count the amount of species that we've seen and quantified.
Yeah, that's exactly what I'm getting at, right? We went out, we put traps out, and we caught, some individuals of these 12 different species. But when we plug in the formula, we're going to say for community A that we actually estimate that there's more than this number of species. We estimate that there's a 13th species that we missed. right? And some of the reasoning for why we would say we can estimate a higher number than what we observe is some species are not easy to capture, right? So our traps might not have been efficient in capturing all the animals out there. Or we also see that there's a couple that have, rare species out there. So we can say, the trapping wasn't very efficient based on multiple rare species. There's likely more than we captured.
So, side note question off of that, is our S value always going to be equal to or greater than our S observed value, or is there going to be some instances where it's lower?
Well, it can't be lower. And why would that be?
Because you
think?
at least your S observed value.
Yeah, exactly. It has to be at least your S observed, because you can't observe 5 species and estimate that there's only 4 there, right? Because we saw 5 in our traps. So yes, exactly. It will always be at least your S observed, and sometimes it will be greater than that. Sometimes it'll be exactly your S observed. If you have no rare species, like nothing had a 1 or a 2, it's probably going to be, you're just going to estimate that it is what you observed because you caught multiples of everything.
Would we be able to do an example of that problem just so I can make sure I have my math right?
We can probably, we can use the one that is in cog books because it does it for all 3 communities, right? So why don't we can walk through community, which one is this? Let's walk through community B together and see what numbers we put in there.
Could you possibly share your screen again?
Yep, sorry, working on that. Okay, so if we look at community B, this is the table we have, right? And we're trying to solve for S, and we're got to fill in S observed and the F1 and F2. So for community B, what is our S observed?
That would still be 12.
Yep, that would be 12 again. What is our F1 going to be?
I got 5.
That's what I see too. The bottom 5 are all values of 1. And then what about our F2? What would that be?
I got 0 for that one.
Yep, I got 0 for that too, because there's no single species that had only 2 individuals observed. So if we plug in 5, we have 5 minus 1 times 5 over 2 times 0 plus 1, so over 2. So what did we get for a final answer on that before I scroll down?
So I got 0. So kind of going back and forth, I got 5 minus 1 each, which equals 4.
Yep.
So that's 9. And then I got 2 times 0 minus 1. So I got 2 times negative 1.
Well, where did you get the negative? Because the 2 would be 0 plus 1 on the bottom.
Oh, that's why I had my thing wrong. I had my sign wrong. So it's 2. So 24. Okay, that's why, because I had my sign wrong.
Or 20 over 2 plus 12, so it'd be 22, right? Because we have 5 times 4 essentially, right? So that gives us 20. And then we have 2 times 1 is 2. We have 20 over 2 is 10. And then the species observed is 12. So 10 plus 12 is 22. Does that make sense?
Yes, that makes sense.
Okay. Why don't we try it again for community C? That's the last one. So what do we have for species observed for community C?
We have 8.
Yep, so we have 8 for that because these all have 0, so we didn't observe them in that community. And then what is our F1? How many organism or how many species had zero, exactly one individual?
That would be 0.
Yeah, right. So we have 0 times 0 minus 1, but 0 times anything is going to be 0. So we're going to have a 0 over the top. And then we have F2. We had a couple values, right? We had 2 organisms, but any 0 over anything is going to be 0. So that's where it just equals our species observed, right? So it's just 8 because we have 0 times 0 minus 1, 2 times 2 plus 1, 0 over 6 is still 0, plus 8 is 8. Does that make sense?
Yeah, that makes sense.
Okay. Yeah, and I would be familiar with how to do these equations because you'll probably see an example or a question very, very similar to this on the exam.
I had a question just regarding some definitions. Would
Sure.
it be fair to say that the ecological niche modeling helps you develop an ecological envelope?
Yes, because what is an ecological envelope?
That's the prediction, right?
Yes, and you use the
Okay.
model based on abiotic and biotic conditions of that organism to make that estimate. So the model can produce the envelope, which is the model of or the estimate of conditions that an organism can survive.
Okay.
It's a good question.
Would you be able to go over the rate of colonization and the rate of extinction?
Sure, that's a good question. I assume it's the equilibrium theory of biodiversity, right? We're talking about?
Yes.
It's like this plot right here. Yeah. So what do we have on here? We have 2 y-axes and 1 shared x-axis. So we do read this from left to right as well as from right to left, depending on which y-axis we're talking about, right? So if we start on the left y-axis, that has a rate of colonization. Now, does that increase or decrease as the number of species increases?
So I'm getting a little mixed up by this. It as your rate of like colonization increases, so does your rate of extinction. Is that correct?
That is, yeah, that is correct.
Okay.
As one goes up, the other goes up, right?
Yeah, I'm
So
getting
I would agree with that.
okay. Can you tell me in like super dumb words why that is? Just because in my head, I keep thinking the more space that you have, essentially, the in my head, it's like the more space that you have, the more room that you have for things to grow versus like the less. I don't know why. It's just I'm getting it confused. I keep thinking that if your colonization rate goes up, then your extinction rate should go down. But I know that that's not true, but it just keeps tripping me up and I don't know why.
Sure. Your first statement I would agree with, that the more space you have, the more room and resources you have for organisms to colonize. So why don't we start with these individually, and we'll build to answering how they interact. How about that?
Okay.
So if we start with just rate of colonization, right? So I was asking if the rate of colonization actually decreases as the number of species on the island increases, right? We can read that, right? That it's a negative slope to the right. Would we agree?
Yeah.
Okay. Why is that? Why does the rate of colonization actually drop when the number of species on the island increases?
Would that be because you have less land space to take up now because there's more things there?
Yes, that's definitely part of it. That's absolutely correct. The more species you have, the more competition you have, the more predation you have, the less space and less resources you have, so it's less likely to get colonized. But if we also think of it as a numbers game, say we have the mainland, we have 100 species on there, and we have an island where we have no species on there. When all 100 species are on the island, no new species can colonize, right? So that's why this actually drops all the way to 0. Once the number is equal, there can be no new colonization. And it's for the biological reasons that you described, that they run out of space, run out of resources, and competition is too high. So does that make sense about why the colonization rate goes down as the number of species goes up?
Yeah, that makes sense.
Okay. And then we have the opposite, whereas the number of species goes up, we have an increase in the rate of extinction. And it is related to some of the ideas we talked about with colonization. So why would extinction go up when we have more species on the island?
You've got more competition, you've got less like places to, how is it? Like you have like less resources, things like that.
Mm-hmm. And when animals are in more confined spaces, they also transmit disease a little bit easier. And the more animals that are, the more species that are on this island, the more types of diseases they're going to bring with them. So yeah, it's competition, limited resources, and disease transmission. All of that leads to higher rates of extinction.
Okay, so what would you do in a like hypothetical scenario, going back to what we were talking about with like the mainland and the island, how if you had, instead of it being like 100 and 0, what would you do in a sense? How would they interact if it was like split in half, if it was like 50-50?
Well, you would get colonization up to a certain point, and then it would probably plateau. And based on this figure, where does it plateau?
Is that right where your S is located, your dot?
Yeah, and what does this S stand for?
The number of your species.
It does, but what does it mean beyond the number of species? Like there's an actual term for this dot.
I'm not sure.
So it's equilibrium, right? So there's a balance of when extinction and colonization cross. This is kind of the level of colonization and extinction we would predict for this scenario. A different island might have different slopes or different steepness to it, but this is where we're going to find equilibrium, and this is the number of species that particular island in this case can generally hold. If we get more colonization, we're likely to get more extinction. To kind of it'll fluctuate a little bit, but as the colonization increases, it'll come back and swing back with more extinction, and it can over extinct, and then that opens up space, and then it can be colonized, but it will hover around this equilibrium point that the island can maintain.
Oh, okay, that makes a lot of sense.
And that's why if we scroll down and we start adding in new scenarios, like we have small and large islands, they actually have different points of equilibrium, right? The larger island can hold more species than the smaller island can because it's further to the right. So it has a higher point of equilibrium, right? Because it has a higher rate of colonization and a lower rate of extinction. Why does a larger island hold more species?
Because it has more areas for colonization.
Yes, presumably a larger island has more resources, it has more space, so it's going to lower levels of competition and species interaction, so less disease transmission and less competition are the two main ones, and maybe even less predation, because if there's more resources such as shelter, there might be more places for organisms to hide. And we make it even more complicated now because we also added distance to the island, right? An island that is further away is going to hold less species than an island that is closer to the mainland. And why? What are some reasons for that?
Would that be because you would have to travel further away from the mainland and not every species is capable of doing that in order to get to the island?
Yeah, I mean, if you have two islands at different distance, the farther one takes more energy, it takes more flight capacity, more swimming capacity. There's more risk of getting, if you're swimming out there, there's a larger matrix in between the mainland and the island. So there's a longer time that you're going to be exposed to potential predators. Or if you have to fly, it's going to take more energy and you're more likely going to land at the closer island than you are at the far island. So that's why close islands get colonized more frequently than further islands do.
Okay, that makes sense.
Yeah, and then if we put it all together, right, we get 4 different equilibriums where we have small far, small near, large far, and large near. And large and near has the greatest number of species, and the small and far has the least number of species that can theoretically colonize that island. All for the reasons that we just described combined.
Okay, that makes sense.
No, those are good questions because you will definitely see this figure on the exam and get some similar questions like which one has the greatest number of species and potentially ask why, or which one has the least amount of species colonizing it and again being asked why.
And kind of piggybacking off of that, so like the equilibrium would presumably change if there were something like a big natural disaster or something that changed the resources available in the area, right?
Yeah, so we don't even get into that, but that is absolutely true. So you could add another layer on top of this. They added, size and distance. You could add number of resources on top of that. So if you had a large island that had a lot of resources, but all of a sudden it had like a volcanic eruption and destroyed everything and had no resources, the odds of colonizing that are pretty low because there's nothing there worth colonizing. Or if a fire wipes it out per se, that the odds of colonization would shrink or decrease rather because of the limited resources.
Okay, so you could pretty much change the curve with any of the ecological factors that it's dependent upon, right?
Yeah, you could. Large and small kind of factor that in because based on probabilities, like a large island and a small island, if they both had fires, the larger island would have more resources remaining potentially compared to the small island, but you could get much more detailed like you're talking.
Okay.
And then previous to this, one of the topics said the head or the title is this larger areas hold more species. And we've talked about resources, but if we get in a little more detail about resources, what else about large areas are different than small areas that would benefit species biodiversity?
Would that be like a variety of resources available?
Exactly. Habitat heterogeneity is exactly what I was getting at. So a larger area is more likely to contain more types of habitat that fill species niches, so you can have more niches available and therefore more species available. So like a small habitat might just be like a single pond or a grass field, but a larger area might contain a pond, a grass field, and a forest, right? So it has all that habitat diversity, which is then going to increase species diversity.
Could we also talk about how fragmentations can enhance or inhibit biodiversity?
Sure. It's a good question. So why don't we break it into two pieces? So when we talk about fragmentation, what do we mean? Like, how would we define habitat fragmentation briefly?
That would be like little patchy areas rather than one large connected area.
Yeah, and what are some examples of fragmentation we can think of?
Would that be like, for instance, hmm, like a bulky forest compared to like trees that have been cut down and now you have little patches of like housing developments in between them?
Yeah, so human interaction creates a lot of fragmentation, exactly, right? It can, even if you have a big forest and you put a road through the middle, now you have two fragments of one big forest that is not technically like continuous anymore. It has that divider. Or a neighborhood is a good example, right? You still have some green around, but now you have a bunch of patches of trees and shrubbery. Yeah, so human intervention or interaction does a lot of fragmentation. It could also be natural disasters too, though, like fires could kind of be a patchy fire and just burn parts of a forest. So now you have, a cleared forest from fire and a normal, non-touched area of forest that didn't get the fire. So it could be human involved, or it could be more natural. All right, so now we defined it a little bit. What does fragmentation do in a negative sense? Why is it negative for animals or other organisms?
They have less space for colonization, reproduction. They're more compact together as far as like their diseases, predation, I think how you say the word, things like that, essentially.
Yeah, so the big one you hit is it just reduces overall space, right? You had a nice big forest and now it's smaller because it's in little patches, right? And what does having, say like a neighborhood, it has a lot of like lawn or something. And if an animal wants to go from one piece of forest through the neighborhood into another piece of forest on the other side, what is it? It has to go through that, what we call a matrix, connecting those two habitats. And our matrix is usually safe or dangerous for animals.
They would be dangerous.
Yeah, so if you're a small animal like a mouse or a squirrel, instead of running through tall grass or through the forest where you have canopy cover, now you have to run through, short lawns or down the road and worry about predators spotting you very easily or getting hit by cars potentially. So it just increases the risk factor for the animals moving between patches. Because, one patch might have water, one patch might have food, and one patch might be where they build a nest, and they've got to use all three patches. So to go between them, they have to expose themselves frequently, which increases their risk of dying.
So
What else? Sorry, go ahead.
how would it enhance species then?
So what does fragmentation increase in an environment?
I mean, it would increase the amount of species that were meant to survive, essentially.
Kind
And
of, yeah. I think you're getting there, but don't think of species, think about the physical environment. How does it we're talking about how it changes the physical environment. It actually adds an element to the physical environment by fragmenting it.
I'm not sure what that would be then.
Are
It
you
incre-
talking about the edge effects?
Yes, absolutely. Yeah, that's what I was exactly getting at. So by fragmenting a habitat, you increase the amount of edge. And what does increasing the amount of edge do to an environment?
Changes the environment. So like you're going to change the species that are specialized for the edge and the climate, because like a forest wouldn't be a forest on the very edge of it.
Yeah, exactly. It increases habitat diversity, right? Because now you would have a lot of, like, say, deep forest habitat and edge around it, but now you have deep forest habitat with edge around it in two circles or something, or two squares. So it'll increase the amount of edge, and that changes the abiotic conditions. So it'll change the temperature, the humidity. it'll change, you know, the soil composition, and that could, you get a lot of edge species, certain plants, certain birds they give examples of are really good in the edge. So it can enhance the diversity by increasing the amount of edge species that come to that environment without necessarily decreasing the amount of interior species in that environment. But it has to be a large enough environment that it doesn't decrease the interior species.
Okay, that makes sense.
And then you could also say that fragmentation like decreases the opportunity for gene flow, right?
It could
With the
if
migration.
yeah, if the distance between the fragmented patches is too great that the organisms can no longer go across the entire landscape, that would be an example of preventing gene flow. So it could isolate small populations, and you could even get some instances of like genetic drift potentially that we'll get into later modules. But yeah, it can definitely have an effect. What's something that they talked about towards the end of the fragmentation units that we can do as humans to kind of mitigate the effects of fragmentation? So even if we build a road, we can put certain things, other structures in place that can lower the effects of fragmentation. Do you remember what those are called?
I can see the picture in my head. Basically, it's like I can't tell you exactly what it's called, but isn't it like those like roadways on top of your roads that have like greenery so animals can cross more safely?
Exactly, right? Yeah, corridors, right? They call them. So they can either build like bridges over highways, or they can kind of build tunnels under roads too. Um, so in theory, they're really good, but what's a negative impact of a corridor?
I think the cog books mentioned predators being able to go across them, right?
Well, predators being able to go across them, or what if a predator learns like there's only one corridor and this is where everything crosses? So if I just sit here, it's like a food buffet for me, right?
Oh, like a bottleneck. That makes sense.
Exactly. So you got to make sure that there's enough corridors that a predator can't just sit at one, that the prey have multiple that they can go across, and that predator has to, you know, if it sits at one, it might get some, but it'll miss others, right? So it can't just feed those predators, that they learn that this is where they feed. So a little bit of planning and make sure that they're, you know, not spaced out too far, and that there is a minimum number to make them effective.
Really quick too, would you be able to just go over your like alpha, beta, and gamma diversity? Um, just as far as like why we have those things and like what the genetic difference is about them.
Sure. So, so how would we define alpha diversity?
Alpha is the number in a relatively small area, or a number of species, I should say, in a relatively small area.
A small area and a homogeneous habitat, right? Or habitat. Sorry. So an example could be a stream, right? Or a pond or a field. So we just think of it as alpha or local scale. And then we have gamma diversity, which is also called regional diversity. And how do we define that?
That is number of species in all habitats that comprise of a large geographic area.
Yeah, so that could be like a number of acres that contains a field, a forest, and a river, right? So it's three different habitats, and that's just more on a larger regional. So alpha and gamma, the difference is just scale, really. And that alpha is a single environment and gamma is all the environments in that regional larger area, so a larger scale. And then how do we define beta diversity?
Beta, number of species that differ in occurrence between the two habitats.
Yeah, so if you want to look at, two local or two alpha habitats, a river versus a forest, and you would estimate the number of species in both, and then the difference between, so it's 10 and 2, so the answer would be 8 in that, hypothetical for the beta diversity.
Okay.
Does that make sense, or did you have more questions about that?
It makes sense in a way. Can you tell me why is it that, say for instance, you got like your 10 and your 2, why is it subtraction instead of addition? Because I think on Cogbooks it had like an example was like stream A plus stream B equals they differ by 8 total species, so their beta diversity is 8. So why is it that you subtract instead of add?
By definition, it says differ, so the difference is a subtraction. But I want to find with what you said. So that's in how to quantify biodiversity, because if I'm not sure I remember it adding, I'm sure it does, I'm just not.
Yeah, because their example was, sorry, I have my toddler. It was, imagine 2 streams. Stream A contains 5 species not found in stream B. Stream B contains 3 species not found in stream A. So stream A and stream B, it was stream A plus stream B equals differ by 8 total species.
So, okay, so because it's the number of species that differ in occurrence between the two habitats, you can say this is you have to account for the different types of species too. So there's going to be some overlap. So if they overlap, they don't differ in occurrence. It's just the unique species to each community. How many unique species are in each community?
Okay, so if you had, for
So
instance, 5 species and 3 were found in B, and then you had 3 species in B, it would just be like 2 plus 3, essentially. It would just be 5.
well, it would be 2, just how many are different.
Okay. Okay. All right, that makes sense.
So you can add the total, it could be, 5 and 5, so you have 10 total species, but only 3 overlap out of those 10. So then how many were unique to each one would be 7, the difference, right?
Yeah, that makes sense.
Okay. No, and I'm glad you asked it that way, because I didn't fully explain it until you brought up when it said how it's unique to those environments. So that's the key word or the key phrase.
Okay, thanks.
No problem. Good question. So another section that sometimes gets a little confusing is when they talked about in module T4, what limits a species range, they talk about the fundamental niche, the realized niche, and the geographic range. So what's the difference between those three, I guess? Why don't we define them and describe how they're all kind of different definitions? So how would we describe a fundamental niche? And if we didn't get that far, that's fine, because we still have a few days before the exam, and this is the 4th section. But if we want to go over this, we can.
Yeah, I was actually going to start that section today after office hours, so I have not started it yet. So if you
Okay.
want to cover it, I'm all for it.
Sure, it's kind of up to the
I
group.
Yeah, I did this one, and this was a section that I struggled with a little bit, just getting the difference between them. Is the fundamental niche more of like a theoretical area, whereas the realized niche is where they actually are?
So neither the fundamental niche nor the realized niche are really measured in area. They're more, it talks about, right, it's the range of abiotic and biotic conditions under which a species can persist.
Okay, so it's like they're factors, not whereas the geographic range is the area.
Yes, and that's, yeah,
Okay.
so yeah, we can say the fundamental niche and the realized niche are different but similar, and then we can distinguish with how the geographic range is different, but it depends on the realized niche, right? So what is the difference between the fundamental and realized niche? Let's start there.
This is where I struggled. I assumed that the fundamental was theoretical, and then the realized was what they were actually in.
That is correct, that statement, right? The fundamental niche is the range of abiotic and biotic conditions that they can survive. And the realized niche is the range of abiotic and biotic conditions in which they're observed surviving. So we think of it in terms, I know this gets a little weird with area, but say maybe we ask the question, why don't we see animals in their fundamental niches? Why do we only see them usually in their realized niches?
Would that be because you can't see something theoretically? You can't say, oh, hey, I'm theoretically going to watch this animal drink from this pond when you can see it clearly drinking from another one.
Sort of. I think we're on the right track with this at least the right train of thought. Can animals get to every environment on Earth?
No.
Yeah, so part of the reason we don't, so maybe there's 2 habitats. We have habitat A and habitat B, but we only see animals in habitat B, and that species hasn't made it to A because there's something preventing them from getting there, right? So say they're on an island and they can't fly or swim. Well, unless humans or transport them, or they transport somehow, they can't get off that island, even though the mainland might have the abiotic and biotic conditions that are, suitable for them. So they just can't physically get there, so they can't leave their, the area that contains the abiotic and biotic conditions of their realized niche. Now, if they can, sometimes the realized niche can be the fundamental niche if they can access all the area that has the conditions that they can survive in. But sometimes the fundamental niche is a broader range than the realized niche.
I see. So maybe theoretical is not the right word, but potential to survive there is a better term.
Yes, absolutely. For fundamental niche, that's where they have everywhere, like every condition that, they can theoretically survive, but maybe where they're living doesn't get, hot, above, say, 20 degrees Celsius. It doesn't get above that, but they can survive up to 25, right? So they're living below their potential. That's a good way to put it. They're living
So
in
like when
temperatures
you're
below.
doing the ecological modeling, you would be, for like maybe invasive species, you would be looking for fundamental niches rather than just the realized niches to try to
Yes.
predict. Okay.
Yeah, you could do that because you could take an animal in a lab and you could say, what is the temperature range that this animal can live? And maybe it can survive, -10 Celsius to 80 Celsius. It's a very big generalist, like it can survive this broad range, but there's not a lot of habitats that have these extreme temperatures, so they're not, fully fulfilling their fundamental niche. Or they're not reaching certain ranges, certain areas that, have those extremes and, fulfilling their fundamental niche. And then we get into the geographic range, that's the actual unit of measure for area of that they're, taking up.
That's really helpful. I was struggling with those three terms.
Yeah. They're not the easiest to grasp right away because, like I said, there's a lot of similarities, but yet there's differences between them. So knowing kind of the both sides of it is definitely how to go about it. Because then we say in the definition that the realized niche determines the geographic range, because the geographic range is where they physically are, and the realized niche are the conditions that we observe them under. And then the fundamental niche are the conditions where we can observe them, but we don't necessarily observe them. It's generally a larger range. And we could say under generally rare circumstances, the fundamental niche and the realized niche could be the same, and therefore, basically they're both determined as geographic range, but that would have to be when organisms, again, are observed under all conditions that they can physically survive in. And that does rarely happen.
Maybe humans would be a good example of that.
Yeah, they would probably be the closest example of that if we think geographically, because why can humans live in a broader range even maybe than their fundamental niche?
Technology.
Yeah, like air conditioning, right? Or heating. We can live in cold places because we develop clothing and electric technology that heats or cools our environment artificially. So what are some reasons that we care about predicting species ranges? Why do we care if a species potentially changes its range?
Could that create more room for different like colonization and like predation, and it can like drastically change your numbers as far as like resources and like disease and things like that?
Yeah, so a couple of those are huge. Like disease is a big one, right? So if disease is contained to a certain area, but under, different, as climate change changes some of the environmental conditions like temperature, some species are able to expand their range northward. So now you have a new species moving into a range that it's never been in before, right? So now you have increased competition, you have the increased potential for disease transmission, you have change in dynamics of resource use and predation. So yeah, there's a bunch of potential for changing the entire kind of dynamic of the ecosystem by having species change their ranges. It could also be for mitigation or prevention strategies. So if there's, say, a locust in another country that's moving its range, a country that's kind of far away might predict like, well, could their fundamental niche be in our country? And if that's true, then we might want to have some preventative measures just in case they eventually make it over here on their own, or they get, they stow away maybe on a cargo plane, or maybe they want to change the way they do trade with that country because they don't want to take the risk they're going to be, that invasive species potentially spreading to their region, because if it does, they've calculated now, its ecological envelope, it could thrive in their country if it ever made it. So they change the way that they do like trade with them. They're a lot more cautious, and they check the cargo a lot more thoroughly to prevent that transportation.
So this is just going to be a very broad question. What is in your eyes, what is going to be the best way to study for this exam?
So I think a good strategy is to use the learning topics for the modules, but I would have read through and answered those as you go through the modules themselves, because that kind of gives you a little bit of purpose as you go through. Because I agree, if you just go through them, it's hard to know what to think about and what to collect, but that gives you a little bit more focus in your readings. You're looking for answers, so you're paying a little bit more attention to the materials themselves. And then you're also asking yourself why and questions about that you can answer and think more critically about the materials. I would also probably go through the modules multiple times, just because you can get through them pretty quickly, but retaining it might take a little bit of a practice. I do recommend also going through the extra materials. Like I said, none of the examples will necessarily be exactly on the exam, but it does help you think about the information and get it presented in a different way. So if you have, the same information presented multiple ways, can be beneficial for remembering it. I would use each other. I understand that this is, a fully online course, but sometimes, a lot of semesters students will create a Discord page where they can meet kind of outside the course, ask each other practice questions, discuss topics that they don't understand quite as well, and just kind of help use each other as resources in the study group the way that students would do in person as well. And that's also why I have the community forum on the page, or on our Canvas page, so students can communicate through that as well too, and potentially develop study groups if they are able.
Okay, thank you.
Yeah. And the last thing, when you read something like a definition, I would always ask myself, why is this the definition? Think in terms of why will get you to think a little bit deeper beyond memorization. And one thing I do want to point out, this is in module 4, T4. It's part of the feedback to critical thinking. How do abiotic conditions limit the fitness of an organism? So the question is, choose one of these abiotic factors, temperature, pH, or osmotic pressure. How would the function of proteins suffer in an organism, or if an organism failed to regulate the abiotic factor? I didn't write the cogbook materials at all, so this course was created and I'm the instructor for it. I don't fully understand why this question was placed here. We don't talk about proteins anywhere in cogbooks, so there's not going to be questions about it on the exam. I understand that there's prerequisites such as general biology, but I just feel that this question is kind of a little bit out of left field. So don't worry about this question or anything really about proteins and bonds for this exam, because it's not going to contain any questions for that.
Thank you. That did seem a little bit random.
Yeah. Yeah, unfortunately, as the instructor, I can't touch the content. I can contact Cogbooks if I find errors in it, but the course creator and Cogbooks wants this in here still, so I can just tell everyone to not worry about it. So.
Can you actually, while I'm just going through all of the notes I've been taking, can you tell me for the geographic regions why Antarctica wasn't included in the southern hemisphere after like once you've got your Gondwana and you've got your Larissa, if that's how you say it. And then once they continued to break apart even more, why your southern hemisphere didn't include Antarctica?
That's a good question. Let me find. So this is in patterns of biodiversity emerged over a long period, I think.
Yes. So you've got, yeah, patterns of biodiversity emerged over a long period. It's right after the second picture where you've got, it's kind of like the world map. It's underneath that.
So is it under biogeographic regions?
Yes.
So you're asking why Antarctica was not part of the southern hemisphere?
Yes, as I was reading it and trying to like, I was writing down each region in the southern hemisphere, and then at the very bottom part of it, after I believe it was the Australian legion, it said Antarctica was not included in this type of model.
Yeah, because in Wallace's delineation, the continent of Antarctica was not included. It could be, I don't know what time frame this was originally written, but it could be that they didn't make it to Antarctica at that time when Wallace wrote this. So they didn't know that there was life down there. I'll have to look into it in more detail to confirm that, but that would be my guess. I honestly don't know. I assume it was lack of knowledge why Antarctica was ignored by Wallace.
I just wanted to make sure that I wasn't including it for like good reasons versus it just being like, no, we just don't, feel like Antarctica should be part of this.
No,
Okay,
because you're absolutely right. The only statement it says is in Wallace's delineation, the continent of Antarctica was not included. So yeah, I'm not entirely sure.
okay, all right,
I would
cool.
I'll look up what year possibly Wallace wrote that, and that could be the why, and just figure out when Australia was kind of, recognized on a map. But
Okay, awesome. Thank you.
'Yep.
Speaking off of that also, would it be beneficial to know each region within the hemispheres for the exam? And like the time periods, so like your your 250 MIA was Pangea, your 100 to your 60, would that be something that's beneficial to know, like what region was in which hemisphere at a certain point in time?
No, don't worry about the timeline. I would be more concerned about knowing, being able to describe the different regions a little bit, like which one's more tropical and which one is more like Arctic or something like that, along those regions or along those lines. So the physical characteristics or the environmental characteristics of the regions, but don't worry about the timelines.
Okay, thank you.
Yep.
So I need to go ahead and get out of here. Thank you, though. This was very helpful.
Sure. Yep, no problem. And glad you can make it.
So before I head off, would you be able to, I did the activity. They called it a quiz on there. I did it and I did okay on it. I just want to understand why, because I think like the shape designs were what kind of confused me a little bit.
Sure.
Um,
And I think I think I know what the designing a nature preserve, is that the quiz you're talking about?
I believe so. It has like the reserve size, number of reserves, proximity, things like that. It's like the circles.
Yeah, let me pull that up. So this is it. Okay, now I think it's sharing, right? So this quiz, right?
Yes, that one.
Okay. So basically it's asking you, what is a worse design for a nature preserve and what is a better design, and thinking about why a little bit. So this is talking about reserve size. So if this is the better design, this circle, what did you say was the worst design?
That would be the small circle.
So this one down here, right?
Yes,
Yeah, and why would a small size reserve be worse than a large size reserve?
because you have less chances for like new populations. You have more like predation, less resources, more disease spread, things like that.
So some of that I would definitely agree with off the bat, like resources, right? So bigger areas generally going to have more resources. But let's talk about some of the other answers you said. You said disease spread. Which reserve, the big circle or the small one, would have higher disease spread?
In my head, I would say I know that it's wrong, but in my head, it's making me think the smaller one just because you're more compacted. But I know that that's not true because you've got more reasonings for disease spread in a larger reserve size?
I would
essentially?
say they could both be potentially true under certain circumstances. So in the small one, if you have the same number of species and animals or organisms in both reserves, the small one, they are going to be more compact and they are going to interact more, and that is going to increase the potential for disease spread by interacting. If they're not the same number and they're based off of the larger one being larger, it's generally going to have more species and more organisms. You can make the argument that that might have a greater chance for disease spread because there's more organisms and there's more types of organisms, increasing the potential for more types of disease in there. So
Yeah.
I would say that that argument you could make kind of either way. But I think the big one here is if we think in terms of like resources, a larger reserve is going to have more space, it's going to have more resources, it's probably going to lower competition than a small reserve. So there's going to be pluses and minuses for both, but overall, a bigger one has more positives than the smaller one.
Okay.
And a bigger reserve, also remember we talked about before, has a higher probability of having increased habitat heterogeneity. So it's going to have, fill more realized niches for organisms than a smaller reserve can. All right, and then the second one they did for us. So this is the number of reserves, and they argue that one big connected one is better than 4 smaller ones. And why would we make that argument that the big solid one is better than 4 broken ones?
That goes back to what we were talking about earlier with what is it, like not having a matrix and being able to have less like fragmentation between your environment essentially for all of your animals. So like it's a lot safer for your species if they're in one confined area like a forest versus it's more dangerous if they have to cross open paths, if what I'm saying makes any sense whatsoever.
Yeah, no, I agree with that, right? The first thing you said was fragmentation, right? And we say generally fragmentation is not always good for an environment. Again, you could make arguments on both sides of these that fragmentation can create some more habitat heterogeneity, which increases diversity, but generally having a larger continuous habitat is going to be better because you can still have the same, amount of heterogeneity because the space is actually the same. So you can get that heterogeneity, but being continuous, I would agree with you saying like they don't have to expose themselves by going between the different habitat patches because we don't know what that matrix is made of. It could be forest, grass, forest. It could be forest, parking lot, forest. It could be water. It could be, something not, something that's dangerous that exposes there, which doesn't necessarily do over here. They don't have to cross any roads in this because it's one continuous versus here, they would potentially have that as an obstacle. So again, there's just more pluses on a large continuous design than there is on a fragmented design. How about reserve proximity? So this has 4 like fragmented patches or broken patches, like we said before. And what do we think would be a worse design over here concerning proximity?
That's going to be your 4 that are kind of spaced out.
Yeah, so this one, right?
Yeah.
So again, I would argue that this has an increased matrix that could be potentially dangerous for those organisms. Maybe this is really far apart and they're not capable of dispersing that long of a distance. So then they become isolated in this one region. And what are small populations at risk of?
They're at risk for like higher I can never say that word, like predation. They're more at risk for not being able to make it to their next destination.
And what do we call it if the population disappears?
Isn't that like extinction?
Yeah, so a small population is at high risk of extinction or a higher risk of extinction than a large population. And if the population shrinks to a small area, there's not going to be enough resources to maintain a large population like it could if it is over in a continuous area or if that matrix is small and it can easily make it between these patches. So if they're trapped in one and there's a efficient predator, they only have to hunt in one of these patches, so their success rate is going to go up. and the odds of them killing them to extinction is also going to go up. Also, if they're trapped there and there's a disease outbreak and that population dies, that species goes extinct, right? They can't, there's not some over here necessarily that, can survive that disease or move out. So it's generally not good to have your patches spaced out for a number of reasons compared to having them in close proximity. All right, and then this one is similar. So we have, again, talking about proximity. So we have 4 patches that are in a straight line. What would be a better design for proximity than having them in a straight line?
That would be the 4 that are, they look kind of like the dice, essentially, like they're, yes, that
Yes,
one.
so this one again, right? And I would argue, truthfully, this would be, better, like, but it's not concerning, proximity is all in one. You could argue having corridors like this, connectivity would be good, but this is not necessarily what is the absolute right answer, what is the best answer given all these different choices, right? So like this could be considered a better, design, but it's better answered for part E than it is for part D. But you could still argue it, I would say, for part D if you wanted. But yeah, having them here again, because this patch to this patch, the proximity is really far versus this patch is equidistant from these two, and this is not quite as far. So just they're in closer proximity, so it's easier to move between the patches so they can utilize different resources, different habitats. They're less vulnerable to predation. They don't get trapped as easily into a small environment because they can move between the patches. And then this one we just answered for connectivity. So these are just 4 isolated patches, and these are 4 patches that have some type of corridor connecting them. So it's easier for them, again, to move between the different fragmented parts. And then for the F, which we only have 2 shapes left, so we obviously know it's the oval or the circle. Which one is the better design, the oval or the circle?
That would be the circle.
Yep, and that's the answer. And why is that the answer?
Because with your oval, you have more edges essentially, and you have less range of space at your max versus your circle. It's like equal all the way around.
Yeah, I would agree. Like there's less edge on the circle over here than there is in that oval because it's stretched out. There's more interior space here. So there's, the area inside the circle is larger. So yeah, for those reasons, that would be a better design for a nature preserve than having tons of edge on more of an oval shape. Because the interior kind of, provides a buffer from, say there's a road here, there's traffic, they can move more to the interior and be under less stress potentially than if they're right, here it's closer to a potential road and, less of a buffer.
Okay, that makes sense. It just looking at the pictures when I was doing the quiz just got me really confused. Yeah.
Sure.
Yeah.
No, that's great. And that's a good question. I'm sure, your classmates will appreciate this discussion if they view it later. And also just thinking of edge versus interior again, the same edge species that can live here, but if this interior has to be so deep, this might not be deep enough to allow certain interior species, but this one will allow those interior species as well as the edge species, which is again why it'll likely have a greater species biodiversity.
Okay. Okay, that makes a lot of sense. Okay. Well, I think that's all of the questions that I potentially have at this current moment in time.
Okay. Yeah, and if you or anyone else have any questions that come up, I'm always available via email or message through there, so we can continue to talk about stuff.
Well, thank you. I really appreciate it. And then I am going to finish section 4 and then study my butt off for this exam on Friday.
Sounds like a good plan.
Awesome. Thank you so much. I really appreciate it.
Yep, no problem.
All right, bye.
All right, and because there's no one else online on the Zoom right now, I'll keep it open until 4:30, but I'm going to turn the camera and audio off unless somebody pops on, and I will make a note of this. if anybody comes on later. Otherwise, if I don't make a note of it, consider this the end of the video.